Hello and welcome to this repair tutorial, and today we're going to look at an Arcam, and this is an Alpha 7R. In terms of general specifications, output is 45 watts per channel into 8 ohms, but this will increase to 80 watts if you connect 4 ohm speakers. Frequency response is 20 Hz to 20 kHz, and total harmonic distortion is 0.01%. For the moving magnet type input sensitivity is 2.7 millivolts. And then for all of your other line inputs, it's 250 millivolts. The amplifier also supports a preamplifier output. This is 510 millivolts. And in terms of speaker impedance, you can connect speakers with an impedance as low as 4 ohms up to a maximum of 16 ohms. In terms of dimensions, height 85 millimeters by a width of 430 and depth of 330. And then the amplifier weight is 4.5 kilograms. It's also provided with a remote control, hence the R. The remote control would be used to place the amplifier into mute, and you can also operate the motorized volume control. But all input selection is manual in terms of operation. Now if we just take a look at the amplifier with the top cover removed, you can see that it's a very clean design. What is nice is that the electrolytic capacitors are high quality, so these are Rubicon. And this amplifier had a full check from an ESR point of view, and all of the electrolytics were found to be very good and well within manufacturer specifications. You can also see that none of the capacitors are close to any power components, which means that the life expectancy is not reduced. You can also see towards the front the motorized volume control, and then to the left hand side there's an IC with a small sticker on top, orange in colour. That is the microcontroller. And then on the right hand side you can see the toroidal transformer, and then towards the rear you have the two main power supply smoothing capacitors. Now when you disassemble this amplifier, and what we show here is the amplifier main board out of the chassis. So what you need to do is just to remove the fixing screws from the rear. You'll also see a number of fixing screws which go through the board. You also need to remove a grounding screw which is to the right of the toroidal transformer, and also the transformer fixing bolt. You can then remove the front fascia, and then what you'll find is that there are two metal tabs left and right where the amplifier screws in from the metal fascia onto the main chassis. Once that's been done, there's just one small PCB pillar which you squeeze in with a set of pliers, and then you can extract the complete assembly that you see here. The good thing about doing it this way is that you're not removing the back panel where the MOSFET output transistors are, etc. So it's much cleaner to work on the amplifier like this. Now, what was the issue when this amplifier came into the workshop? Well, it is indeed the most common issue that gets reported. And this is where you have intermittent sound loss, either left or right channel. And the owner would report that if they operated the input selection switch, sometimes it would go away and then sometimes it would come back. What you see here is the underside of the main board. And always, if you listen to these tutorials, you'll note that I just draw these red circles that you see, highlighting common areas which require attention. The reason for the intermittent loss of sound is caused by either dry solder joints on the input selection switch, but more commonly you'll find that there is oxidization on the switching contacts, and the switch must be removed, taken apart and then cleaned, but we'll get to that in a moment. Each one of these areas highlighted indicate where there are dry solder connections. So anywhere where there is a stress point or there is heat, you need to pay more attention. So here you would resolder all of the input RCA sockets. You can also see as well the small heat sinks. So this is where the output MOSFETs are, and often the amount of solder on the MOSFET connections is very light. So again, resolder. And then you can also see the speaker terminals, and then to the right hand side and the rear is the input power socket. There is always dry joints. And then as we move towards the front of the amplifier closest to the multimeter, right hand side is the headphone socket, all of the user controls, and then you also have the plus or minus 15 volt regulators, and then as I mentioned a moment ago, those connections there are the input selection switch. If we just take a bit more of a detailed view and we zoom in, really these solder connections here, and this is on the bass and treble controls, is very sparse. And if you looked in more detail, you'll find that there's actually cracking around the pins as they come through. Don't forget as well that the motorized volume control will also have dry solder connections as well on the potentiometer. So just use an adjustable spanner. Don't use a pair of pliers because you don't want to damage the locking nut. And then you can unscrew it and then just withdraw it and make the reflow of the solder connections. This photograph here is a perfect example of how light the solder is. So this is the headphone socket. You need to put a substantial amount of solder on there just to make sure that there's no future issues. The other thing, and you can see from this photograph, as we look down, this is the speaker protection relay. Now, as a matter of course, because of the age of the amplifier, I simply just replace it. And you'll see in the description for the video the part number and manufacturer type. But it's a sealed relay, so you can't open it up and try and clean the contacts. The issue often with the speaker protection relays, and it's common to all amplifiers, is over the years of operation, the contacts become oxidized internally. And also, where maybe it's a higher power output amplifier, the contacts become worn, and then you'll find this intermittent loss of sound. And sometimes if you take maybe a flat screwdriver handle and just tap the top, sometimes that will clear the fault. But remember, it's resistive, that's what it's become. And it can also lead to low levels of distortion at minimum volume levels. So here, what we show in more detail is the input selection switch. So what you have is what we term as two wafers, and then you have the wiper of the switch. Now, when it's removed, you have to bend back these lugs, and then you can take off the rear faceplate. And what I'm showing here is really a combination of two things. The first one is the oxidization on the switching contacts. But during manufacture, they also put a lubricating grease on there, and this grease becomes solidified and acts as an insulator. Hence, when the owner is selecting different inputs, sometimes it's making a positive connection and sometimes it doesn't. Hence the intermittent loss of sound. And then here, I'm just showing you the example where on the left hand side is the remaining wafer, which has not yet been cleaned. And then on the right hand side is the rear wafer, and that has been cleaned then with the device. And you can just see it to the left. That is a fiberglass pencil. Please do not use anything more abrasive than that, because you'll damage the contacts. So just use the fiberglass pencil just to wipe over the contacts, and you'll see that they'll come up very, very bright and clean. I also spray as well with De-Oxit, and then just put some De-Oxit lubricating grease and then reassemble the switch. And what you'll find then is that this amplifier will deliver good performance year in, year out for decades. The final part of the repair and service routine is really to do the alignment. So this is where you're going to adjust the left and right hand channels, and you're going to return it back to the original setting as it was when it left the factory. Over time, what can happen is that the bias may drift high or it may drift low. So here on the circuit schematic, you can see that you have the preset potentiometers, and two of them, one for the left and one for the right. And then what you are doing is you are measuring across these resistors as indicated. And what you need to do is to leave the amplifier to warm up for about 20 minutes and then make your adjustment. So here we just step through. So I'm showing you here on the left channel, and you can see that it's 2.57 millivolts. So what I do is I just make the adjustment, and then you can see here that we're within the required range. So it's 3.32 millivolts. And then here on the right hand channel, again it was low, 2.85 millivolts. And then after adjustment, you can see here that we're about 3.35 millivolts. So well within the range which is specified for the bias. Now do refer to the service manual, which is readily available in the public domain, just to verify and to check depending on what Arcam amplifier you have, because some of the other models the bias is lower than the setting that you see here. And then finally what we show is this zoom in view. So this is the Omron relay. So this is a 24 volt coil, and it is a double pole changeover relay and readily available. And then the final part of the service and repair is twofold. The first one is to place the amplifier onto test, and it runs on in test conditions for about 4 hours. And then the other point is to clean the amplifier. So that sort of brings us to the end of this repair tutorial. So as always, I really appreciate you stopping by, and if you need any help, support or guidance, by all means email audioamplifierservicing@aol.com, and I'll be more than happy to come back to you and provide the support that is requested. So until the next time, I wish you all the very best. Cheers and bye-bye.